Welcome to Senior High School Math Series. Let us have probability distribution of discrete random variables under statistics and probability. Q3 Week 2 based on curriculum implementation and learning management matrix for K-12's most essential learning competencies. Here are our learning competencies. Construct the probability distribution of discrete random variable and its corresponding histogram. Compute probabilities corresponding to a given random variable. Before we continue, let us have this from Pierre Laplace. The theory of probabilities is at bottom nothing but common sense reduced to calculus. Let us begin the lesson with ponder on this. Histogram is one of the most commonly used graphs in research. After a data is organized into a frequency distribution, it can be presented in a graphical form. This is essential because it is easier for people to comprehend the meaning of data when presented in graphical form than when presented in purely numerical, either in tables or frequency distribution. That is the purpose of graphs in statistics, to convey data to the audience in pictorial form. The same is true in probability distribution. The corresponding probability for each outcome is easily compared when presented graphically using the histogram. Probability distributions can be represented graphically by assigning values of the outcomes in an experiment and their corresponding probabilities on the x-axis and y-axis respectively. So let's start with definition 3.1. A discrete probability distribution is a table, graph, or formula showing the values of a random variable can assume and their corresponding probabilities. The probabilities are either theoretically determined or obtained through observation. To construct the probability distribution of a discrete random variable, consider the family with 3 children in example 1.3. Recall the sample space is represented as the set with elements 3Gs, 2Gs, and 1B in different arrangements, 2Bs and 1G in different arrangements, 3Bs. If x is the random variable for the number of boys, then x assumes the values 0, 1, 2, or 3. The probabilities for the values of x can be determined as follows. No boy, 3Gs, that is 1 out of the 8 elements in the set. When there is one boy, the elements are GGB, GBG, BGG. Each is 1 out of 8. So we have 3 over 8. When there are 2 boys, we have the elements BBG, BGB, GBB, also 3 out of 8 elements in the set. When there are 3 boys, that is also 1 out of 8. Therefore, the probability of having no boy is 1/8. 1 boy is 3/8. 2 boys is 3/8. And 3 boys is 1/8. Using table of values, the probability distribution can be constructed by listing the values that x assumes. We write them on the first row, and then the corresponding probabilities for each value of x on the second row. The histogram for the number of boys in a family with 3 children is shown in the following. On the y-axis are the probabilities, and on the x-axis are the values that x assumes, In this case, the number of boys. Let us have another example. Example 3.1. According to the Caloocan City Fact Sheet on 2015 Census of Population by the Philippine Statistics Authority, the average household size in the city is 4.3. Letter A. Construct a probability distribution for a member to be female in a household of 4 members. Letter B. Construct a histogram for the data. Let us have our solution. The sample space is 0, 1, 2, 3, 4. That is no female, 1 female, 2 females, 3 females, and 4 females in the household. And the probability distribution is as follows. So the values that X assumes will be written on the first row, and in column will be their corresponding probabilities. So the probability that there is no female in a household of 4 members is 1/16. With 1 female is 4/16. 2 females, the probability is 6/16. 3 females, the probability is 4/16. 4 females, the probability is 1/16. Solving for probability is getting the ratio between the number of females in the household and the sample space. If we have 4 members in the household, there will be 2⁴ number of elements in the sample space, and if there is no female, that will be all males, and that is 1/16 in the sample space. The histogram for the probability distribution is as follows. On the x-axis are the values of X, which is the number of females, and on the y-axis are the corresponding probabilities for each value of X. So when there is no female, that is 1/16. 1 female, that is 4/16. 2 females, that is 6/16. 3 females, that is 4/16. And 4 females in the household, that will be 1/16. The requirements for a probability distribution are as follows. The sum of the probabilities of all the events in the sample space must be equal to 1. So when we add all the probabilities of the values of X, it must be equal to 1. The probability of each event in the sample space must be between or equal to 0 and 1. Remember that when an event will surely happen, the probability is 1. And when an event is not likely to happen, the probability is 0. When an event has a chance of occurring, then the probability is a value between 0 and 1. Probability of an event cannot be a negative value. Also, the probability of an event cannot be any value that is greater than 1. The discrete probability distribution for a random variable or its histogram may be used in computing probabilities. Let us have example 3.2. A pizza restaurant listed the number of pan pizzas a customer buys during the week so that they would have an idea about the number of pan pizzas may be sold for the next set of customers, and they had the following distribution. Let x be the number of pan pizzas that may be sold. So if x equals 1, the probability is 0.41. If x equals 2, the probability is 0.24. If x equals 3, the probability is 0.10. If x equals 4, the probability is 0.11. If x equals 5, the probability is 0.08. If x equals 6, the probability is 0.06. So let us check if the probability distribution satisfies the requirements. So we see that there is no negative probability. And let us get the sum. 0.41 plus 0.24 is 0.65, plus 0.10 is 0.75, plus 0.11 is 0.86, plus 0.08, 0.94, plus 0.06, that is equal to 1.00. So it satisfies the requirements for the probability distribution that the sum of all the probabilities is equal to 1. And also, there is no probability that is more than 1, nor negative probability. If x is the number of pan pizzas per customer, letter A, what is the probability that the next customer will buy 1 pan pizza? Letter B, out of the next 200 customers, how many would buy less than 4 pan pizzas? Let us answer. Using the discrete probability distribution for the random variable, it can easily be seen that the probability that the next customer would buy 1 pan pizza is 0.41, or we say 41%. Letter B. Out of the next 200 customers, to find the number of customers who would buy less than 4 pan pizzas is to add all the probabilities corresponding to the number of pan pizzas that is less than 4, then multiply the result by 200. Hence, the probability that x is less than 4 is equal to the probability of the event that x equals 1 plus probability of the event that x equals 2 plus probability of the event that x equals 3. Let us substitute the values. For x equals 1, 0.41. For x equals 2, 0.24. For x equals 3, 0.10. Then the probability for the event that x is less than 4 is 0.75. Next, we multiply this by 200. Therefore, there are 150 customers who would buy less than 4 pan pizzas. Let us have some practice exercises. In the practice exercises, you will be given 15 seconds to answer the problem. If you need more time, you may pause the video and then play again to check whether your answer is correct. Let us begin. Identify whether each of the following is a discrete probability distribution. If not, state the reason why. Number 1, go. Time is up. The answer. This is a discrete probability distribution. Next. Go. Time is up. The answer. This is a discrete probability distribution. Checking the requirements for a discrete probability distribution, we see that there is no negative probability. No probability is greater than 1. Let us check the sum. 1/3, when the denominator is 12, this is 4 twelves. 1/6, when the denominator is 12, this is 2 over 12. So we have 4 plus 5, 9, plus 2, 11, plus 1, 12 over 12. That is equal to 1. Next, go. Time is up. Let us check the answer. This is not a discrete probability distribution. Why? Because the sum of all the probabilities is greater than 1. Let us see. 0.53 plus 0.42 is 0.95, plus 0.15, that is 1.10, plus 0.11, that is 1.21. So it exceeds 1. Therefore, this is not a discrete probability distribution. Next, go. Time is up. Let us check the answer. This is a discrete probability distribution. Notice that there is a negative value for x, but that is allowed. Checking the requirements for the p of x, this probability distribution satisfies the requirements. So this is a discrete probability distribution. Next, go. Time is up. Let us see the answer. This is not a discrete probability distribution because we have a negative probability. The probability of the event should be equal or greater than 0 but less than or equal to 1. Next, let us have number 2. The probability that a grade 10 completer from a public high school in Caloocan is considering 1, 2, or 3 senior high school institutions are 3/5, 3/10, and 1/10 respectively. Construct the probability distribution and sketch the histogram for the data. Go. Time is up. Let us see the answers. The probability distribution for the data is as follows. The values that x assumes are 1, 2, and 3, and their corresponding probabilities 3/5, 3/10, 1/10. The histogram for the data is as follows. On the x-axis are the values of x, 1, 2, and 3. And on the y-axis are their corresponding probabilities, 1/10, 3/10, and then 3/5. So if x equals 1, that is 1, 2, 3, 4, 5, 6 out of 10, or 3 over 5. If x equals 2, that is 3 over 10. And if x equals 3, that is 1 over 10. The probability that a tarpaulin printing shop has a demand for 2, 3, 5, or 7 birthday greetings tarp on any given day are 0.4, 0.37, 0.17, and 0.06 respectively. Construct the probability distribution for the data. Time is up, let us check. So the probability distribution for the data is as follows. So the values of x are 2, 3, 5, and 7, and their corresponding probabilities on the second row. 0.4 if x equals 2, 0.37 if x equals 3, 0.17 if x equals 5, and 0.06 if x equals 7. The sum of the probabilities must be equal to 1. 0.4 plus 0.37 is 0.77, plus 0.17 is 0.94, plus 0.06, that is equal to 1. There is no negative probability in here, and there is no probability that exceeds 1. Therefore, our probability distribution is correct. For more exercises on probability distribution of discrete random variable, copy of the exercises may be downloaded from the link given on the description of this video. That is all. Thank you for watching. Please subscribe for more math lessons.